Hi everyone, welcome to Workshop 3, Finite State Machines. My name is David Schoening. I am one of the OP instructors here. I will be joined by Antonio and Gavin, who are both OPS instructors for this year, and we'll be talking about finite state machines with the iPodawino project.
So what is a finite state machine? A finite state machine, or an FSM, is a model that is used to design and represent control flow in systems with a finite number of states. They are also known as finite state automatons. We have an example below of a finite state machine diagram and what it would look like, but I'll cover more on this later in the next slide. So the structure of an FSM is made up of states and transitions. States represent the information stored by the system and are denoted by circles. Take, for example, the FSM we have below, which models the different states that a person might go through in a typical day. Home, work, and bed are three different states that are modeled in this finite state machine and are denoted as the circles that you see below. On the other hand, transitions represent the movement between states and occur when a certain input or condition is satisfied. They're denoted by the arrows, and their conditions are often written along the arrow. Now, in this example below, let's say that I start at state home. If I wanted to get to work, I must satisfy the condition of the transition that would take me to work, in this case, taking the train. Once this condition is satisfied, our FSM transitions from state home to state work. Likewise, if I wanted to go back home, I must satisfy the condition of the transition pointing back home, which is also taking the train once again. And once that condition is satisfied, you guessed it, we are back home. So how can an FSM be used in embedded systems? Well, FSMs are a great way to implement the control flow of a system into code in an intuitive and efficient manner. And FSMs can be implemented in numerous program languages, but we will use and implement FSMs using C and C++ through control statements such as if statements and switch statements, and also enumerated types.
In the previous section, we went over what a finite state machine is and how it works. In this section, we'll make a finite state machine using a vending machine as an example. So let's lay out some ground rules first for the vending machine. We want to create a vending machine that will only accept quarters, no other coins, and it will have a numpad with 3 buttons, allowing us to input either 1, 2, or 3. The machine will be locked until money is inserted, and when the user inserts a quarter, they may select one of the options from the numpad. Depending on the selection from the numpad, the vending machine will either output cola, ginger ale, or root beer. After the drink is dispensed, the machine will then lock again. So let's create a diagram for this FSM. The first thing that we want to do is establish each of our states. So as we mentioned, one of the requirements is that before anything is inserted, the vending machine will remain locked. And at the very end, after a drink is dispensed, it will go back to a locked state. So the first thing that would be good to do is to establish a locked state. We also mentioned that we want there to be an input from a numpad, 1, 2, or 3. So we can input a state where we would receive one of the transitions going from, or transitions depending on if the input is 1, 2, or 3. Finally, we want to either dispense cola, ginger ale, or root beer based on that input. So we can put the states dispense ginger ale, cola, or root beer. Now that we have our states established, we can now talk about our transitions. So the first thing is, of course, moving from the lock state to the numpad selection. If a quarter is inserted, then we would move on to numpad selection. So we can just simply write that as a transition saying if a quarter is inserted. Next, depending on the input from the numpad, we want to either dispense cola, ginger ale, or root beer, if it's 1, 2, or 3. So we can write a transition that depends on if the numpad input is 1, 2, or 3. Finally, after our drink is dispensed, we want to go back to the lock state. So regardless of which drink state that we end up on, we want to move back to the lock state. So we can simply put a transition saying if the soda is dispensed, move back to the lock state. So now you can see our complete FSM. and how it'll flow back to the beginning after our final state. So, okay, now let's talk about bettering the machine. So let's say that the user enters a coin that is not a quarter, and we want the vending machine to not do anything until they enter a quarter. How should we show this and how should we account for it? So already the FSM will only move on if a quarter is inserted. But if something is inserted as not a quarter, then the FSM doesn't know where to move on to. So we can simply we can account for this by having a simple uh transition that'll transition back to the original state that it's at. Uh, it'll just loop back to its original state. So here we can see if point inserted is equal to 0, or these two lines represent an or, the coin is not equal to a quarter. Exclamation mark and equal sign is equal to, or means not equal to. Thus, if the coin, if no coin is inserted or the coin is not a quarter, then the machine will remain locked. It'll just loop back to the locked state. Let's say if they enter a coin that is not a quarter, but we want to refund that coin. We can depict that through adding an additional refund state. So now instead, if coin is inserted and the coin is not a quarter, we can move to the refund state, which would return back the quarter and loop back to the lock state. Very simple.
Now we will talk about building an FSM for our iPod Arduino. First, the requirements for our iPod Arduino. So the first requirement is the player must play 3 songs and it will have 2 buttons for us to interact with. One of those buttons will toggle between a play and a pause mode. When the iPod Arduino is in play mode, the player must play back a song and it should resume the song that was previously played if the skip or next song was not pressed. When it's in pause mode, no song should be played. The second button will be the skip or next song button, and this interrupts our current song and then plays a new song. Each press of this button must cycle through all 3 songs. If the player was in pause mode, then it'll play mode into the next song. Here we have a diagram for our FSM. We have our start state, our play song 1 state, play song 2 state, play song 3 state, and play song, and then the pause song 1, pause song 2 state, and pause song 3 state. And then as you can see, we have arrows which are not labeled to show the transitions between each of the states. You can now take the time to fill in each of those transitions depending on our 2 inputs, the play and the pause button, as well as the skip and next button. Now we will look at some coding for the FSM for iPod Arduino. So here we have some code for iPod Arduino. We start off defining our ints for the pin layout. So we have the play and pause button pin, the skip and next button pin, as well as our speaker pin. Next we have an enum. An enum allows us to define the states that will be in our program. It is like our ints where we are defining something, but in this case, the states remain inside of the program. They aren't actually found in the hardware. And so we enum the states of start, playing song 1, playing song 2, playing song 3, as well as pause song 1, pause song 2, pause song 3. And now we initialize those variables to values. So we start with our current state in the start state. We have our play button and our skip next button to be false. And now we label those pins. So we actually map the play and pause button to a pin for the input, as well as a skip button for an input. And we also label our speaker pin as our output. We also initialize our serial communication if we need to use the serial monitor for debugging. And now we jump into the actual loop of our code. First, we want to read our play and pause button as well as our skip button to see if there are any changes to the values if the user presses it. And now we come to a switch statement. A switch statement is common to an if-else statement where but this case it will read one variable and then it'll match that variable to one of the cases following it. So it reads the current state. If the current state is case start, then it will follow whatever is below that case start. So here we have the if statements and break, or it will keep reading all of the cases until it finds whatever until it finds whichever one matches that current state. So for our case start, we see if the play or pause button is equal to high, then our current state becomes playing song 1. That means if the play or pause button is pressed, meaning it's high, then our current state becomes playing song 1 and we play it. Playing song 2, if the play or pause button is equal to high and our current song, then our current state will become the pause song 1, meaning we are playing the song and then we press it and we pause it. But if we play the skip button, then we begin playing song 2. For playing song 2, we do the same. If we're playing it and we press the pause button, we pause the song, but then we skip it if we press the skip button and play song 3. And then song 3, we loop back to song 1. Now for the pause buttons, if we press the play or pause button and the state becomes high, then the current state becomes playing song 1, so the reverse. And then skip button high becomes playing song 2 as well. Now for pause song 2, the same thing. If we press the play or pause button, it becomes playing song 2, but the skip button becomes playing song 3, and then same follows for play song 3. And then here we have the 3 functions for the play music, pause music, and resume music. The code that you see here will compile, but it will not fully work for our iPod Arduino project. You will have to define each of these functions to work inside of each of the case statements when the state is changed and called, as well as a few other things. But overall, this structure for working for an FSM dealing with an iPod Arduino will work. And then finally, a funny misquote by Danny DeVito: life is like a finite state machine. Sometimes you're in the happy state, other times you're in the confused state, and occasionally you find yourself in the error state. Just keep transitioning. Thank you for listening to this workshop 3 for your iPod Arduino project. We hope you had a lot of enjoyment